Hello, everyone. My name is Ali Zahori, and for my research project, I decided to focus on the Tasmanian bluegum eucalyptus, also known by its scientific name as Eucalyptus globulus, and its impact on species richness and biodiversity within the Sierra Azul Preserve. So, a brief overview of Eucalyptus globulus is that it has many beneficial uses, such as being used among the pharmaceutical industry, as for for cough and cold medication, specifically cough syrups, for uh, joint pain ointments, in addition to insecticides against ticks. Um, Additionally, the wood from Eucalyptus globulus has been used to make many cultural instruments, such as the didgeridoo, which is a popular instrument used among the indigenous peoples of Australia. Furthermore, it is also the primary source of food for koala bears. However, apart from these beneficial uses, from an ecological standpoint, it has been known to have many devastating effects, both as an invasive species and a significant threat to wildfire-prone communities. Um, as mentioned before, the tree originated from southeastern Australia and eventually made its way to California during the time of the gold rush in the 1840s, where it spread rapidly throughout the state as many prospectors saw the wood as a effective alternative to many of the native trees grown in California at the time. So, for this research project, I came up with two major research questions. The first one was that whether or not there would be a difference between eucalyptus dominant and oak dominant woodland sites. And my second being that the three as to what were the three major native and invasive species that were observed within both woodland types. So in order for me to conduct my research, I conducted 5 line transect surveys for 5 eucalyptus dominant sites and 5 oak dominant sites through the use of simple random sampling. From there, I was able to utilize random number generator websites such as wheeldecide.com and random.org to randomize the size for both my transect and for my site size. From there, I then analyzed various parameters such as species richness, um, or basically how much of each plant species was located within a woodland type, or within each site. Soil type, so whether the soil was silty, clay, sandy, loamy, or peaty. Site size, um, and it could also be noticed that the number of plants within each woodland was my main unit of analysis. From there, I then compiled my raw data and categorized them based on the parameters which I mentioned previously. And then I would then conduct various statistical analyses on Excel, ranging from descriptive statistics, an ANOVA test, and various t-tests, with my alpha level of significance being 0.05 for each of the statistical analyses. And so doing so helped me to obtain these two graphs. So the graph on the left is essentially for all of the species that were observed within all eucalyptus dominant woodland sites in the Sierra Azul Preserve. And so it can be noted that the top 3 invasive species were the Mediterranean storksbill, French broom, and Italian thistle, while the top 3 prominent native species were graceful bedstraw, uh, trailing blackberry, and catchweed bedstraw. And although it is quite small, these are also represented on the chart as having the larger bars on the bar chart. Additionally, you might notice that there's another chart very similar to this one on the right. This is for the oak dominant woodland sites. And so right off the bat, you can already tell that the oak dominant woodland sites tend to have more species on average. As it was noted that throughout my research that many of the oak woodland types did have a higher rate of species richness and biodiversity. However, that was also coupled with the fact that it had a higher rate of invasive species as well. The reason why we don't really see that in the eucalyptus dominant woodland sites is because the peeling tree bark from the Eucalyptus globulus has essentially covered the entire canopy cover for the forest or for the woodland type that the trees are present in, making it very hard for other plants to sprout beyond the peeling bark, which has for the most part blocked any paths of sunlight for any smaller plant species, with the only exceptions being the Pacific poison oak and the California bay laurel, which were the only two plants that were strong enough to essentially reach out through the bark of the Eucalyptus globulus to obtain natural resources such as water and sunlight. However, the top three uh, uh, invasive species that were noted in oak dominant woodlands invasive species were French broom, Eucalyptus globulus, and calla lily, while the native species was catchweed bedstraw, knotted hedge parsley, and the Pacific poison oak. And so, in conclusion, Eucalyptus globulus has been known to have various yet devastating impacts on a variety of woodlands throughout California. However, it can be noted that once again, oak dominant sites tended to have a higher rate of invasive species rather than Eucalyptus globulus. However, Eucalyptus globulus is also problematic because its peeling bark has been shown to prevent any other plants from developing, due to the immense piles of bark being so immense that these any small plants would essentially be crushed under the immense weight. Additionally, it can be noted that some other research that could be done regarding Eucalyptus globulus could be on the spread of Eucalyptus globulus in regard to certain avian species and how certain bird species might be responsible for spreading the seeds of Eucalyptus globulus and helping them to spread throughout other woodland types throughout California. In addition to that, tracking the spread of Eucalyptus globulus in relation to wildfires and various wildfire-prone communities is also important, as their peeling bark has been known to be highly combustible and could prove to be very detrimental to many of these communities as climate change and increasing global temperatures continue to put many of these communities and woodlands under a greater amount of pressure. But yeah, that's about it. This is my poster. This QR code at the bottom is for the sources I have cited in this presentation. And I thank everyone who is watching this right now.